In this video, we're going to look at balancing chemical equations. Okay, so chemical reaction occurs when two elements or compounds react together to form a new substance. Okay, and we can represent those reactions by chemical equations. Okay, so one thing with these chemical equations though is that they need to be balanced. So you have to have the same number of each element on both sides of your equation. So if we have an example of magnesium, Mg, reacting with oxygen, okay, oxygen only exists in nature as O2 by itself, okay, and that will give us MgO, magnesium oxide. Okay, so that chemical equation, well, it does tell us what's happening. It doesn't have a balanced number of atoms at each side. So magnesium does react with oxygen to give you magnesium oxide, but you have to have the same number of each element. Okay, so if we look at our left hand side, which is our reactants, we see that if we look at magnesium, we have one magnesium. Okay, on this side we'll represent that maybe as orange. Okay, so we have one magnesium atom at this side. Meanwhile, we have two oxygens. Okay, so we have two oxygens on our left hand side. We're represented by this 2. Okay, so the subscripts are relating to the element they come after. Now, if we look at our right side of the equation, all right, we look at magnesium, and again we have one magnesium, so that's fine. Okay, so we have one magnesium, which is fine. But if we look at our oxygens, we see that there's just one oxygen by itself. It's just MgO. Okay, so that would mean that we only have one oxygen. Okay, and if we look at the number of each, that doesn't add up. Okay, so you have one magnesium and two oxygens, and then on your right hand side you only have one oxygen. So we need to find a way to have the same number on both sides. Now, if we're just looking at our oxygens, all right, we obviously need a second oxygen on the right hand side of your equation. Okay, the simplest way to do that will be to put a number in front of our magnesium oxide. Okay, so you can't just put a 2 here, because that's changing the compound that you're making. Okay, so that's why you can't put a subscript. When you're balancing chemical equations, you can only the coefficient that comes before. Okay, now again, with your coefficient, you can't put it in the middle of a compound, so you can't have Mg and a big 2 in here for oxygen. Okay, that you're not allowed, you can't do that. Okay, you have to put the 2 in front of the whole compound, because remember that this magnesium is bonded to this oxygen. They're one molecule. Okay, they're one thing. Okay, so really I suppose down here what I should have done is have a magnesium bonded to an oxygen. Okay, now so if we want to balance our oxygens, then we're going to have to put a 2 in front of our magnesium oxide. So that means now, yes, we do have 2 oxygens. We have a second oxygen here. Okay, but it also means we have a second magnesium. Okay, so that means now we have 2 magnesium oxide molecules on our right hand side. Okay, so you've made 2 MgO. So you've one MgO here, and you have a second MgO there. What that does mean now, though, is that you have 2 magnesiums, which means on your left hand side, when you go back, you have to do a final check to make sure that it all adds up. Okay, that it all adds up, and you see now that your magnesiums don't balance. So the simplest way to rectify that is to put a 2 in front of the Mg. Okay, and then you're going to have a second magnesium. So that means now you have 2 magnesiums on the left. So you have 2 magnesiums, you have 2 oxygens, and they're reacting together to give you 2 MgO. So again, here you have 2 magnesiums, and you also have 2 oxygens. Now, if we look at another example, we're going to move on to a different example. We're going to look at methane, which is CH4, and that is reacting with oxygen. Okay, so oxygen is O2. Okay, so on our left hand side we have we have 1 carbon, we have 4 hydrogens. Okay, that 4 just relates to the hydrogen and it has nothing about the number of carbons. And here we have 2 oxygens. Okay, that reaction gives us carbon dioxide, CO2, and it also gives us water, H2O. Now, okay, so on the right hand side of our equation, the product side, we also have 1 carbon, we have 2 oxygens there, we have 2 hydrogens, we have 1 more oxygen. So that means in total we have 3 oxygens on the right hand side of our equation, which doesn't balance. Okay, and we also only have 2 hydrogens, which also doesn't balance. Okay, so again, I'm just going to draw these out. Okay, so you have 1 carbon, we have we have 4 hydrogens. Okay, now they're bonded together, they're one compound, but we'll represent them like that for now. Okay, then we have 2 oxygens on this side. Then when we go to the left, or the right side of our equation, again we have 1 carbon. We have 3 oxygens. And we have 2 hydrogens. Okay, so clearly we have less hydrogens and we have 1 more oxygen on our right hand side. Now, if we look at the numbers that we're dealing with, it's easier to balance the hydrogens first. Okay, so if we put a coefficient of 2 on our H2O, that now means we have 2 molecules, we have 2 water molecules, so we have 2 H2Os. Okay, so that now means we have 2 more hydrogens. Okay, meaning that we have 4 hydrogens on our right hand side. Okay, which balances with our 4 hydrogens on our left hand side. So we have 4 and 4. Now, what that also does do though is mean that we now have 2 oxygens over here. So we actually have 1 more oxygen molecule than we had before. Okay, so now we have 4 oxygens. Okay, now that of course doesn't balance because we have 4 oxygens now on our right and we only have 2 on our left hand side. So we want to come to a situation where we have 4 oxygens on both sides. So that means we're going to put another coefficient in. So we're going to have 2 O2s. Okay, so that means 2 more oxygen molecules, or oxygen atoms on this side. So we now have 4, which balances. And just have a final look again with our carbons. We didn't touch our carbons really, so we still have 1 on both sides. So we have 1 carbon, 4 hydrogens and 4 oxygens on both sides of our chemical equation. The next example we're going to look at is going to be Ki, which is potassium iodide. So Ki is potassium iodide, and we're going to react that with chlorine, Cl. Okay, similar to oxygen, it exists by itself, only as Cl2. You don't really ever see just a Cl by itself. Okay, in most situations. Okay, those that go on to do leaving cert chemistry, you'll see variations of that. Okay, and then we have our products then are KCl plus I2, which is iodine. Now, okay, so if we have a check again, all right, we have 1 potassium and we have 1 potassium. If we use orange for our iodine, we have 1 iodine. On this side we have 2 iodines. And then with our chlorines, we have 2. We might use a different color. Use purple. Okay, so chlorine, 2 on the left, and when it's bonded to potassium, we only have 1 chlorine. Now, okay, so we see that our potassiums are balanced at the moment, but our chlorines are not. Okay. Just so there's no confusion between the L's and the I's. Now, okay, so if we look at our either of them, to be honest, okay, let's go with the iodine just because it's by itself. It's on the right hand side. Okay, if we look at our iodine, we have 2. On the left, we only have 1. Okay, so on the left, we need to have 2 iodines. So we're going to put coefficient of 2 on that potassium iodide. So that now means we have 2 iodines on the left, and we also have 2 iodines on the right. That does mean, however, that 2 relates to the potassium also. So we have 2 potassiums now on the left, while we only have 1 on the right. So that means we're going to have to put a 2 in front of this KCl. And now we have 2 potassiums. What that also means is that the Cl is multiplied by 2 as well. So now actually we have a second chlorine, which balances our chlorines also. Okay, so we have 2 potassiums, 2 potassiums. We have 2 iodines, we have 2 chlorines, we have 2 chlorines, and we have 2 iodines. And we're just going to take a look at one final example. What we're going to do is we're going to react sodium. Sodium is Na. And we're going to react that with water, H2O, and our products from that are NaOH, which is sodium hydroxide, which we should know from our acids and bases chapter. And we're also going to produce hydrogen gas, so H2. Now, okay, so we're going to just start the process again of trying to balance these. So our sodiums, we have one sodium on the left, we have one sodium on the right in our products. Okay, so for now our sodiums are okay. Our hydrogens, okay, our hydrogens, we'll try and keep them the same color, why not, yellow. Okay, so we have two hydrogens on our left on our reactants. We have one hydrogen here in NaOH, and we also have two hydrogens here as H2. So in total we have three hydrogens on the right, so that's not balanced. And then if we look at our oxygens, we'll have, look at our oxygens, we have one oxygen on the left in our reactants, and we have one oxygen in our products. Okay, so the only thing that isn't balancing at the moment is our hydrogens, because we have 3 in our products and we have only 2 in our reactants. Okay, so we have to look at both sides of our equation and try and come up with a way that would possibly balance this. Okay, it's a little bit difficult maybe when we have 3 and 2. You might be tempted to multiply by 1.5, something like that. So 2 multiplied by 1.5 will give you 3. But we want to try and stick with whole numbers all the time if we can. There could be a bit of trial and error involved here, so you might try something, it might not work, and you might have to go back and try another set of numbers, okay? So there is trial and error involved in this, but over time you'll develop the skills to be able to do them a little bit easier, and your instincts doing them will improve over time. Okay, so if we look at this, okay, what we might do is we would, okay, we have 3 hydrogens over here, we only have 2. What if we multiplied our water over here by 2? That would then mean we have 2 H2s, so that totals 4 hydrogens. Okay, but now we also have 2 oxygens. Okay, so that obviously doesn't quite add up. Now we have 4 hydrogens on our left, and we only have 3 on our right. We have 2 oxygens on our left, and we only have 1 on our right. If we look at a compound that has both hydrogen and oxygen in it, this NaOH, what happens if we multiply that by 2? Okay, now we have 2 oxygens, and all of a sudden now we have another hydrogen also. Okay, so that now means we have 2 oxygens, 4 hydrogens. It also means that our sodium has been multiplied by 2, and we now have 2 sodiums. Okay, so now we have satisfied that our hydrogens are balanced. We're also satisfied that our oxygens are balanced. Okay, so 4 hydrogens, 2 oxygens. Okay, but now we have 2 sodiums and we have 1 sodium. So we're going to multiply our sodium on the left by 2. And now we have 2 sodiums. We'll do one last check as we look across to see if all of our elements are balanced. Okay, we have the same number of atoms of each. Okay, so we have 2 sodiums on the left, we have 2 sodiums on the right. We have 4 hydrogens on the left, we have 4 hydrogens on the right, and we have 2 oxygens on the left, and we have 2 oxygens on our right. So now our chemical equation is balanced. Okay, so for junior cert, we look mainly at simpler molecules. So that last one there would be probably as difficult as it would get for junior cert. Anyone that goes on to study Leaving Cert, they get a little bit more complicated as we have more complex molecules. But if you're able to do those 3 or 4 examples we went through there, you are good for junior cert. Okay.